Alright, ladies and gentlemen, it is time to learn about dilutions. So dilutions are actually a really important part of laboratory science, especially chemistry. This is something that I have to do a lot, so this really hits close to home for me. So a dilution is when we take a concentrated solution, which is called a stock solution. So a stock solution is usually what they sell solutions in. So a stock solution is pure, concentrated. It's really, really hearty stuff. So what would happen then is I would buy at the beginning of the year a concentrated solution of hydrochloric acid. That's something I use a lot. It's something that we in labs use a lot. You guys have used it quite a few times already. So if you look at the different bottles of hydrochloric acid that we've used in labs, we've used things like 1 molar, we've used 0.01 molar, and all different kinds of concentrations. If at the beginning of the year I had to buy all of the concentrations that I'm going to be using of hydrochloric acid, I would end up ordering a ton of different things. So instead, what I usually order is a bottle of 12 molar hydrochloric acid, which is pure hydrochloric acid, and it is extremely hazardous, and you can't fly with a jug of it. But from that, I can take samples of that, I can dilute them down to create the different concentrations that I need. So if I needed a 1 molar or a 0.01 molar, what I could do is I could pull some of my stock solution out, so get a small sample of it, and what I'd get there is I'd get a certain, amount of the moles of hydrochloric acid. So that stuff from the concentration, remembering that molarity is stuff per liters, or in real science terms, moles per liter. And so I would pull out a certain number of moles and put it inside of here, along with a little bit of the volume. So I'd pull that out, put it in there, and then I could fill it up the rest of the way with water. Then what's going to happen is that hydrochloric acid, it'll mix up in there, and it will lower the concentration. And so it'll go from 12 molar, I'll dilute it with water and turn it into 1 molar. And then I can do the same thing from the same jug, pull that out, put it into another beaker, get a small sample and fill it up with even more water. And that will then spread throughout the whole thing, and it will dilute it to a concentration of 0.01. And I can pick any concentration I want, and I can add a certain amount of water and create that concentration for use in the lab. It's a brilliant thing. But you can thank me later. For now, I'm going to teach you how to do a dilution equation. Here is the equation that you're going to use. M1 times V1 equals M2 times V2. So they're not written in there, but those are variables, just like in math class, really, that's times that's in between them. So M1 times V1 equals M2 times V2. What those little numbers underneath mean, 1 means this is what you have on hand. This is what you have before. So like my 12 molar hydrochloric acid, that would be my M1. M2 and V2, this is what you want or need. So keywords to look for, because a lot of these are going to be word questions, story problems. Watch out for the words have and want or need, because that's going to be a hint as to what the different letters mean. So M1 and V1. M number 1, that would be your original molarity. So that would be the concentration of the stuff that you're starting with, so your beginning concentration. V1 would be the volume of that original molarity that you need. So let's think back to that picture I showed you guys before with the concentrated hydrochloric acid and then me diluting it down to different things. So I've got a 12 molar jug of HCl, and I need to make let's say a 0.5 molar solution. So my original molarity, my M1, is going to be this right here. It's going to be what I start with. And then I'm going to take a certain size of that out, a certain sample of that out, and put it into the other one. The amount that I pull out of this jug is going to be my V1. So here we have my M1, 12 molar, and my V1 would be the amount that I take out to create our new concentration. The other two variables are going to be M2 and V2. M2 is going to be our desired molarity, so the molarity that we want to achieve. And that's going to be this number right here. So my M1 is the concentration that I'm starting with, my M2 is the concentration that I want, the 0.5. The V2 is going to be the desired final volume. So let's say I need 500 milliliters. of 0.5 molar HCl. That's going to be my desired volume. That's going to be my V2. So I know what I'm starting with. I'm starting with 12 molar HCl. I know what I need. I need 500 milliliters of 0.5 molar HCl. The question is, how much do I need to transfer over? So how much do I need to pull out of my stock jug into this other beaker before I fill it up to 500 milliliters? That's where this equation comes in handy. So M1 times V1. My M1 is 12 molar. My V1, that is unknown, so we're just going to put it in as a variable. My M2, my molarity that I want, is going to be 0.5 molar. And the volume that I need is 500 milliliters. Alright, let's solve this algebra style. So 0.5 times 500 equals 250. And we need to get, so V1's by itself, so let's divide both sides by 12 molar. And that's going to give us our V1. So when we do that, we find out that V1 is equal to, with sig figs, 21 milliliters. So that means in order to create a 0.5 molar solution that we're going to need for a lab, I'm going to take my 12 molar jug, I'm going to pull out 21 milliliters, I'm going to put it in another beaker, and then I'm going to fill that beaker up to 500 milliliters with water. What that means then is I'm not going to add 500 milliliters of water. Instead, I'm going to add enough water to create 500 milliliters. So if we're starting with 21 milliliters of the HCl in here, that's 21 milliliters. How much water do I need to add in order to create 500 milliliters, so to raise it all the way up to 500 milliliters? Well, if I need 500 and I'm already at 21, that means I'm going to need to add 500 minus 21, which is 479 milliliters. And that's how much H2O I will add. Okay, so to create this, I'm going to pull out 21 milliliters of the 12 molar, put it in a beaker, add 479 milliliters of water, and bada bing, bada boom, I got myself 500 milliliters of 0.5 molar HCl. And the name of the compound doesn't really matter. It can be anything. We can do sodium hydroxide, sodium chloride, silver nitrate. Any solution we can dilute with this exact same equation. Just know what we're starting with, figure out how much we need, and there we can make ourselves a nice diluted solution to any concentration we desire. Any concentration. A word from our sponsors about V2. So the term V2 can be very, very challenging, and that's because it is the final total volume. The final total volume, which means the volume of your initial stuff, so your stock solution, plus the water that you add. So say this with me, everybody. Final total volume. Once more, V2 is the final total volume. I want to hear everybody saying it this time. Final total volume. What that means is that V2 is equal to V1 plus the H2O, the water that has been added. So it's not just how much water you add. That's the trick. Like in that example I just showed you, we didn't solve for how much water we're going to add, or we didn't know how much water we were going to add. We had to figure that out. So it's V1, your initial stuff, plus water to get it up to that final volume. Once more, everybody with me, final total volume. Ethan Biener, I want to hear you say it by yourself. Final total volume. Good job, guys. Hey, you think you got it? Here's a great chance to pause the video, read through this problem, and give it a shot. Then resume the video to check your answer. If you still want to see how it's done, keep the video playing and follow along at home. So suppose we want to make 250 milliliters of 0.1 molar copper sulfate solution, and we have a stock solution, so we go to the back room and we have 1 molar copper sulfate. How many milliliters of 1 molar copper sulfate would we need? Let's make a couple annotations on this problem. So first off, notice this word want. So that's what we're going to try and get. That means those are going to be the two numbers. So we want to make 250 milliliters. That's a volume. And since it's what we want, that means it's volume 2. And we want 0.1 molar. So that means that's going to be our M2. That's our desired molarity. And what we have, so there's that word have, is a stock solution of 1 molar. So that's going to be our M1. How many milliliters, there's a volume, do we need? So that's going to be our V1. So we're going to need a certain volume of this 1 molar sulfate in order to create our solution. So now let's go ahead and create our equation. So our M1 is the 1 molar. Our V1, that's our unknown, so let's put it in as V1. Our M2, that is 0.1 molar. And our V2, I'm sorry, is 250 milliliters. Alright, so rearrange this here equation, and you can solve it out and find out that you need 25 milliliters. So what that means is you're going to go to the back room, you're going to grab your 1 molar copper sulfate, you're going to pull out 25 milliliters, you're going to squirt it in a beaker, and then you're going to fill it up to 250 milliliters. So how much water are we going to add? Well, if we have 25 milliliters in there, and we want it to be 250 milliliters, we're going to have to add 225 milliliters of water, which will then create our final volume of 250 milliliters. Alright, I can tell you're starting to get this, so go ahead and try pausing the video on this one, read through the question, and then resume it when you're ready to check your answer or if you need a little bit of guidance. Alright, you can see that I've annotated the different pieces of information. So we have M1, we have M2 and V2, we're looking for V1 again. So let's take the numbers, plug them into our equations, leave our unknown as a variable. Do a little bit of algebra here, and we can solve for V1, and we can find out that we need 150 milliliters of the 3 molar sulfuric acid solution. And then we would fill it up to 450, which means we're going to need to add 300 milliliters of water. And that's going to create our solution of 1 molar sulfuric acid. This one's a little bit different. Read through it very carefully and give it a shot. The question for this one is how much water do we need to add in order to create this solution? Alright, I've labeled the pieces of the puzzle, and we're going to have an initial volume of 100 milliliters, and it's a 5 molar solution. We want to get it down to 3 molar. So how much water are we going to need to pour into the beaker in order to get it to 3 molar? In order to figure that out, we're going to need to know what the final volume of our solution will end up being. And so we write this out, and we can go ahead and solve for some V2. And with a little bit of mathematics, we can learn that we need 167 milliliters as our final volume. So hey, remember, this is our V2. This is not how much water we add. This is the final volume. The final volume. Remember that V2 is equal to the V1 plus the H2O added. So what we want to know is how much water needs to be added, because that's what the question is asking us for. So if V2 is 167 milliliters and it's V1 plus H2O, that means the H2O volume is going to be equal to 167 minus our initial volume, so what started off in the flask, which was 100 milliliters. That's milliliters. So that means we're going to need to add 67 milliliters of H2O. So if you want to visualize this a little bit better so you kind of get an idea of what I'm talking about here, let's draw a picture just to remember from the beginning of this unit what this looks like. Alright, so I started off with a 5 molar jug, and my goal is to create a 3 molar solution. So what that means is I need to remove 100 milliliters of this guy, because that's my V1 and my M1 was the 5. And so this beaker initially is going to have only 100 milliliters of a solution in there. I do the calculation and I find out that my V2, my final volume that I want, so what I want this to reach up to when I pour water in here, is 167 milliliters. So my goal is 167 milliliters. Now, if I just straight up pour 167 milliliters of water into this beaker, it's not going to fill it up to that point right there. It's going to fill it above that point because I'm already starting with 100 milliliters. It would fill it up to the 267 milliliter mark, and that's no bueno. So in order to get it right to the 167 mark, I need to add an additional 67 milliliters of water. And that 67 milliliters of H2O is going to bring it up to exactly that line right there, and we will be golden. That's it, ladies and gentlemen. Try the practice problems on the website. You can check your answers automatically now, and I'll see you in class.